server-side WebAssembly, where versions range from 0.3 to 3 to 25.
In this episode, we get to chat with Mikkel about WebAssembly then and now, Spin 3.0, WASI 0.3, and Spin moving into a sandbox project for the CNCF.
And Laura took her shot. She got us talking about the enterprise, FML.
Of course I had to. At least we talked about Rust. Enjoy this episode.
Welcome, Mikkel. Thank you for joining us. This is Cloud Native Compass, and we're excited to pick your brain on everything Cloud Native, Fermyon, WebAssembly, and Spin. For anyone who is not familiar with you, Fermyon, or Spin, please feel free to introduce yourself now.
Thank you, David, and thanks for having me. So my name is Mikkel Mørk Hegnhøj. I am Danish, which is why you would hear that weird surname. I am the head of product and developer relationships at Fermyon, where I've been for, and now I actually don't know whether it's 2 or 3 years. So you pick whichever one you want. I think it's actually 3 years. At Fermyon, we are doing WebAssembly. We talk about it as the next wave of cloud computing, which is why it's so well aligned with the topic of cloud native, hopefully you're going to talk about today. Prior to being at Fermyon, I spent more than 10 years in Microsoft building various cloud services and developer tools there, which is also where I met Matt and Radu, who are the founders of Fermyon, and how I sort of got involved in all of this.
Excellent.
Awesome, thank you. Now, of course, I want us to chat about Spin, which as of November, only a few months ago, released version 3. So the pace at which that project is evolving is fantastic to watch. But I think we should set a little bit of context and just talk about WebAssembly and the evolution of that over the last 3 years, if you've seen it. No surprise to anyone who's listened to this podcast before or seen any of my YouTube stuff. I'm quite bullish on WebAssembly. I think it's an enabler and something that everyone needs to start paying more attention to. Mm-hmm. And I'd love to hear your version of it as someone from the inside who's actively trying to make this possible for developers to adopt and succeed with WebAssembly. Yeah. What have those last 3 years been like for you, and how is WebAssembly evolving?
The last few years, and I actually think it's 3 years now that I get to think about it.
Yes.
Thank you, Laura. You're confirming me. Thanks for keeping me straight. It actually says something about how quick time has passed, but also how much have happened. Like you have that weird paradox that you feel like time just like snaps away, but then on the other hand side, there's so many things have happened. And I actually think that's a good indication that a lot has happened. Like we really moved forward, and just to think back to even November when we did Spin 3.0 and where we are today, even more has happened. So yeah. So it's an interesting space. I think over the last 3 years, the whole ecosystem around WebAssembly has, my first encounter with it when I joined Fermyon 3 years ago was just trying to figure out what's even going on here. What's the ecosystem trying to accomplish? Lots and lots of really great and promising visionary stuff, but less practical things that were usable and approachable for people to actually do things with. Whereas over these 3 years, that has really flipped. I think a lot of the visions has come to fruition, and I hope we get to talk about the upcoming WASI 3 as well, which is another big milestone in what you can do with WebAssembly, but also seeing Spin and a lot of other projects in the WebAssembly space really bringing this in the hands of developers, that it's easy to get to. There's great developer experiences. You can easily build applications, managed services popping up, so it's easy for you to actually run them. The ability to run things in Kubernetes, and really try to get WebAssembly as a core primitive of cloud computing in all those places where you expect to, or where you do cloud native computing today. And I think I used the tagline, the next wave of cloud computing, when I introduced myself. I think I did something along the lines, but that's really what we think about WebAssembly here in the progression that we've seen from all the way back from physical servers to virtual servers to containers, and then being WebAssembly and the new kid on the block in terms of that core primitive into how we do cloud native things.
Nice. There's quite a lot I feel we can dig into there. And
Yes.
I'm going to try not to go down. I love that. The next wave of cloud computing. And I think we'll leave this here. We're going to come back to this to talk about how building WebAssembly applications and operating WebAssembly applications is different from traditional container-based or VM-based applications. We'll come back to that for sure. But you talked about WASI 0.3 there.
Yep.
And I don't want to be foolish, but I'm going to try and say, when WebAssembly first came out, it was just a browser-based sandbox. WASI is what brought WebAssembly to the server. And I believe 0.1, there was no such thing as the component model. The runtimes all implemented their own interface things. And then with 0.2, the component model came along and said, well, actually, let's have shared interfaces to provide shared behaviors with different implementations. And I believe the Fermyon team was maybe not spearheading, maybe you were spearheading, but you were definitely a major part of that conversation. As we progress to 0.3, is this us leading to something that is truly ubiquitous from a WebAssembly and server-side point of view for people to adopt it now? Because in my head, in one of the conversations I have, sorry, I'm now going to go on for ages in chat.
Yep.
When I go to conferences, I'm always going WebAssembly and waving my hands and trying to get people to listen to me. And one of the major concerns is 0.2 from the WASI, right? Isn't that too early? And on the opposite side of this, we've got Spin, which is on version 3, which is built on top of WASI 0.x. So what is the stability here? How do we get people to... There's two questions here. One, what is 0.3? Where is this taking us? And then are we at a stable point for people to start kicking the tires on this stuff?
Yes. I like to think of these in terms of, if you were to look for stability, you should not... So WASI is a specification. Let's start there. Like WASI specification, right? And the specification typically has a long time to move from releases to releases, in terms of there's a lot of alignment and agreement that needs to happen in the ecosystem, which I think is good because the specification needs time to prove itself before it stabilizes, because that's going to end up being the foundation where, the main promise of longevity of what you end up building comes in, promises of portability between implementations and so on and so forth. That's where you snap that to in terms of what the specification is. And there are definitely scenarios where some of that has more impact and is more important than other scenarios. So if you think about the runtime implementation, so for instance, Wasm time is one of the most popular WASI runtimes that exist. I think there's a nuance to this, is like, how do you even apply your versioning concepts? Because Wasm time is, I think, version 25 or something like that. Because they basically have a way of saying every time we do a version, we do a major version release. And that's how you can think about the runtime and what they do. But what most people will end up taking a direct dependency on would be the tools and the implementations which they as developers would write against. Spin being one of those, right? Which is a framework and a developer tool that is where you're going to meet WebAssembly in many cases. And there are other examples of Spin besides Spin as well, and more of these come up in various scenarios. And Spin then, across its major versions, then obviously has support for the underlying specifications. But Spin is where that's at least been our approach to that project, has been like, Spin is where we're going to give you the promises of backward compatibility. And we have across Spin 1 and 2 and 3, which we're at right now as the major versions, kept the backward compatibility for things that we have been able to run previously, which means you can still run things that are not WASI 01, even with Spin 3.0. So if you wrote things to that specification, that's still supported at that point. So I think it's important for people in terms of how they think about this. What are the tools they're going to implement against? What is the direct dependency they have? And do they rely on that dependency to do the long-term support across the specification revving? Yeah, at least that's how I think about it. And knowing that we are early on with some of the specification pieces, at least I think it's important for the frameworks that people use directly, that they help with the promise of longer term support and backward compatibility.
Yeah, you talking there for a few minutes has given me a kind of a eureka moment in my head. And I think I'm going to condense everything you've just said into a single sentence, and I hope you're not too offended. But I think from a developer standpoint, exactly what I want is slow-moving specifications that I can trust to still be there, but fast-moving implementations that can iterate and provide me what I need to be successful as a developer.
Can I write that down?
That way.
Yeah. Yes, you can write it down.
I'll just say that next time around.
But yeah, I'd never viewed it through that lens before. But yeah, I want my specifications to evolve slowly, with the implementations providing that test bed to iterate, advance, test things, kick the tires and all that. So I really like that. And even though the WASI specification is 0.2 moving on to 0.3, these things have been in the works for a long time as well. WebAssembly is not exactly a new concept. It's been around since, I don't want to just throw out a year and hope that I'm right, but I think it's like 2016, 2017. Maybe I'm wrong.
That's a great question.
It's
I don't know when that was.
Someone should go and Google it, but but you're probably right. Yeah.
So I was going to say, now I'm not as up on WebAssembly as David is. I'm kind of that person in the call. But last I remember, there was a move from building on top of, I think it was Nomad, and now it mostly builds on top of Kubernetes. So from like an operator standpoint, I'm curious from that perspective of, has that move been a significant one? Throw this out there. As you start thinking for like Spin 4.0
Mm-hmm.
and whatever's next for WebAssembly, are you thinking that you'll probably stay on Kubernetes, or do you think you might branch out to try to encourage even more adoption?
I'm pretty sure Kubernetes is the path to get adoption. I think if anything you will find in most companies that run things is that you can be pretty certain as a developer, if you hand over a container to your operations department, they know how to run it.
Right.
And they probably will use Kubernetes in 95% of the cases or something like that. So I think that's a given for sort of like the mass adoption. It's true that at Fermyon, we did create something we called the Fermyon platform on Nomad to begin with, mainly because we didn't see a good solution to run other types of workloads inside of Kubernetes than containers. And that was really the main thing why we picked up Nomad at that point in time, because Nomad are able to run even just processes along with containers and other things, and that's how we packaged that. So the big invention that happened there, which was together with, well, actually Microsoft did a concept called Run WASI, which was a way to provide which evolved into a way of providing a shim for Containerd, the runtime, to not only be able to run containers, but also to run WebAssembly natively, so to speak, right? So you don't wrap a WebAssembly in a container, you basically run the WebAssembly directly. And with that component, it sort of solved like what we didn't take on at that point in time is you now have native WebAssembly support in Kubernetes by using Containerd and using that shim, which means that it makes so much more sense to start running inside of Kubernetes. So if you take that compared with the breadth of adoption of Kubernetes, I think that's definitely the way forward.
That makes sense.
Yeah, to add on more context there, just because like this is now my dream situation. We're talking about WebAssembly and Kubernetes side by side. So if we bring in some Rust.
Yeah, I was going to say, where's the Rust in here? Let's go.
The reason that serverless workloads on top of Kubernetes sometimes have a bad time and get a bad reputation is because in order to actually start a container or a pod inside of Kubernetes, there's a whole bunch of assumptions that needs to be made. One is it needs to speak to the CNI and get an IP address. It needs to speak to the Linux kernel and get C groups and namespaces and all this stuff. Meaning that the base or the bottom line for starting a container is actually measured in usually hundreds of milliseconds. Now, there are ways to improve that, but hundreds of milliseconds. Yeah. And for WebAssembly, I don't think that makes sense. I believe it's Radu, Fermyon, who's always talking about the invocation and startup time for a WebAssembly binary is measured in nanoseconds and not milliseconds.
Yeah.
And when you realize why would you take all of that performance improvements and throw it away just to run it on Kubernetes? There's a lot of things that need to be challenged and changed there. And I loved what the Microsoft team are doing with Run WASI to enable this, because it provides that new bedrock, that new framework that allows these WebAssembly applications to maintain velocity without sacrificing the runtime environment. Because Mikkel just said, everyone has Kubernetes. I don't even think HashiCorp are running Nomad anymore. They're at KubeCon too talking about Kubernetes. So
that is, I don't know.
The fact that we can have our stateful container-based databases running side by side with a future of hopefully WebAssembly invocations, I think is a powerful future that we should all be aspiring to eventually. And it's just, how do we get there? How do we onboard more developers? And I'm sure Mikkel's got all these answers in his back pocket. We can dive into that. But how do we go from, okay, we've got WASI 0.3 coming up, hot on our heels. We've got SpinCube now, which is open source and released that allows people to run these WebAssembly workloads natively on Kubernetes, side by side with everything else. We now need to get them right in Kubernetes WebAssembly applications. And voila, now we're on to Spin 3. Like, why don't you give us the TLDR? Why should people start paying more attention to Spin? And what did the V3 release bring to the table?
So I think I just want to make a small remark on what you said on the performance thing, because the way that I think about that in my head is that I think what we've done with Run WASI and SpinCube, so SpinCube being the project that pulls all of these things together with easy Helm chart installs, and then you just deploy the Spin app, but basically it's all the underlying technology stacked up and operators and so on and so forth, is we've ensured that Kubernetes is sort of that a Spin application in WebAssembly can become a first-class citizen inside of Kubernetes, right? So when you operate these in Kubernetes, you operate them the same way you would operate a container there, which also gives you the huge benefits that the whole ecosystem around Kubernetes just worked with this. Last week, I did a recording of an introduction to SpinCube that involved showing how you can just apply a Kita scaler to your WebAssembly workloads, right? The same way you do to your container workloads, which is a really good example of just fitting into the broader ecosystem, which I think is part of the answer to getting the adoption, right? Like the same way that operations teams or platform engineering teams provide platforms that support containers, it's really easy for them to enable now just supporting WebAssembly inside of the same platform that way. I think the missing piece there, to your point about performance, is work to be done to have Kubernetes being a first-class host for WebAssembly, meaning that you actually get the full benefits of, for instance, the scaling to zero and starting from zero, not the lack of cold start, but the fact that there hardly is any cold start going from not having a WebAssembly component loaded and then loading it. We've done runtimes in that, around that, as a commercial project for Fermyon, where basically we can host 10,000 applications, WebAssembly applications on a single Kubernetes node. But we can't do that in the Kubernetes model because of pod limits and those type of things, which means we have to break out of that being the first class citizen. So there is that trade-off there, right? That sort of speaks to that. But I think being a first-class citizen in Kubernetes is part of the road to adoption. So back to your question, David, about what we've done in Spin 3.0. The main things that we have been focusing on in Spin 3.0 is this idea of WebAssembly components. And it's actually also a good sort of, there's a tie back to when we talked about WASI 03, and that being sort of the next release of the specification. The marquee feature that WASI 03 will bring in the specification is to be able to do a combination of async and sync programming between components. So we might want to talk a little bit about what WebAssembly components are so that we get an idea of what this is. So WASI stands for the WebAssembly System Interface. So it's basically a set of APIs that you need to implement if you create a WASI compliant runtime, which means that it's a virtual machine, it's like an operating system. So if you write a WebAssembly and using these APIs, you expect that WebAssembly to be able to run inside a WASI compliant runtime. But WASI is also so together with WASI, a way of describing those APIs and interfaces called WIT, which is the WebAssembly interface type language, was developed, but it actually enables you to define your own set of interfaces and APIs through WIT. And what's interesting about WIT is that WIT is meant to bridge the same way that a WebAssembly, you can say, is portable at runtime because it's a bytecode format and you have this virtual machine. What WIT enables us to do is has a definition that the programming languages now can understand. So you can have a definition of an interface that you can provide in a Rust implementation and use in a JavaScript implementation, which means that you can actually have libraries, which is what we will normally call them when we're in a single programming language, from other programming language that you use in whatever code you're writing today. And in the WebAssembly world, we call these, when they're compiled, we call them components. So you can implement a WebAssembly component in a given programming language that you can now go and use in another WebAssembly component written in another programming language. There's a path of this, which is just polyglot development. And then it's like, well, I don't want to break down my libraries in different programming languages. Because I use one programming language normally, right? But there's another path of this, there's another way of telling the story, which is maybe it's the package managers and all package managers. Like, if someone wrote a really secure and fast Postgres driver in given language, we don't have to write a Postgres driver in all these other languages when we're using the WebAssembly world, because we can basically just use that component from other programming languages. So the component model is a core focus in 0.3.0, where now between these libraries, we're actually able to combine synchronous and asynchronous functions that work inside of each of these components, unlocking a whole breadth of scenarios, particularly around streams and other things where you want to stream data. I think it's one of the typical use cases that will light up there. Yeah.
So this means I haven't been keeping up with 0.3, so this is new to me, but I'm loving where this is going already. This is essentially like a distributed promise across any language, where, again, if I got an async function in JavaScript, it does a fetch request to a remote host, but I call that from Rust. It's able to handle the promise in JavaScript, return a response, but it's handled at the WebAssembly world point of view rather than in each individual component itself. Is that correct?
Yes.
That sounded like a yes and no rather than just a yes. But
Yeah, I don't know what the no would be. Yes.
That's really cool. I like where that's going. And
the main thing here that we've discovered is that there are certain frameworks and programming languages that makes such heavy use of async. So one of the things that people may have stumbled upon when they've been looking into WebAssembly is but there are all these things you can't do, right? There's probably still garbage collection, multi-threading, or things that people used to take onto. And there's definitely things because it's not a full operating system. It's not a full libc compatible thing. people expect other places. A lot of these frameworks just take assumptions that we're not able to honor in WebAssembly yet, right? So it's just yet another step on this ladder of making more. I think the effect of this will be that more stock libraries you get from your NPMs and your Cargo or your NuGets or wherever will actually just work at WebAssembly once we have 0.3.0 working. That's really the net effect of this.
People just compile down to one layer and everything can work together. It makes sense.
Yeah.
Yeah, just preaching to myself here. I'm a Polyglot developer. I don't, as much as I would like to write most things in Rust.
Yeah.
I definitely appreciate having that option to jump out to writing some Go where it's appropriate. I like writing Elixir. I like playing with Ponylang. I like playing with Zig. If there's a language that's something interesting, I generally like to play with it. And I feel like WebAssembly, and especially WASI and server-side stuff, just allows me to sit down and experiment with all these things. And having spent the first 10 years of my life writing nothing but C and Perl, you get locked into how things are done in those ecosystems. And it's not until you start experimenting and playing with more languages that I feel that I broadened as a developer and began to pick up new patterns and new paradigms, and I think made me a better and stronger developer. I encourage people to look at it from that lens. Don't just sit and write Go because the entire cloud native ecosystem is in Go. There's a lot to learn from Rust and Elixir and Zig and all these other really cool languages. Just this week, I seen a language library shared on GitHub. Someone started it, and it was an actor framework written in Swift. And I like distributed systems. I like actor-based systems. And I've never played with Swift, so I went and lost 3 hours of my day just playing and taking the start of that. But it's fun. You've got to find moments of joy as well when you're doing this stuff, right? That's what stops you, hopefully, from burning out and just having a smile on your face for you too.
I mean, just the diversity of ideas that are implemented and concepts that are implemented, just like, I think enables you to reasoning about things in a different way. Just like hearing other people's opinions, which is also always inspiring, right?
Definitely.
I just hear that you're enabling David's "oh shiny" syndrome is what I'm hearing. So that's very classic. It's very nice.
Yeah, it is.
And I thank them for it.
There's a very specific scenario that we did end up writing a few weeks back because someone requested it, which was like, hey, I'm a JavaScript developer and I want to do something really easy that I can deploy into a low compute environment, but I actually want to do image manipulation. What's a great way of doing image manipulation? JavaScript is, we can just implement a component in Rust over here and use a really efficient Rust library to do image manipulation, expose the features to an interface defined in bit, and now you just wrap the HTTP request in your JavaScript and you call into the Rust component that actually does sort of the heavy lifting, right? So I think there's another thing, which is, using some of these programming languages appropriately where they're really easy. JavaScript is easy with HTTP and JSON. Rust is not necessarily easy with HTTP and JSON, but it can do other things well, right? So I think that's a good sort of more down-to-earth practical use case for this type of polyglot.
Right.
Yeah, and if we also expand the scope a little bit, people write applications that run server side. Some people write applications that run front end. There's desktop applications, there's mobile applications. There's a lot of opportunity for interrupt. But they require you to use different language. Yes, sure, you can use Electron for desktop and mobile and all right, but we all like native feeling apps that work well within each ecosystem. And WebAssembly gives us this wonderful integration point as well, where you can have shared type definitions that can be consumed across the entire stack, which, I mean, I spent a lot of time doing this with JSON schema and GraphQL and a whole bunch of other Arvo type languages, and then you're always compiling the language specific assets for this, and it's cumbersome, it's painful, especially when you go across multiple repositories and multiple projects and you've got versioning and distribution. Right? Sure, I could throw all in NPM, but do I want to do that? No. And I think there's better ways now, and WebAssembly is front and center with that regard, at least in my opinion. So again, I said I'm bullish. I'm not going to shy away from saying that I really like where WebAssembly is going, and more people need to be doing this. So.
From an enterprise standpoint, though, it's actually very useful because you're not really having to deal with a lot of the, how do I chase the new thing that I need to do and get more developers to work on that, but I still need to maintain all of these tools and things that I've built that are running in older development systems and older languages. So you can't staff up for everything if you have to constantly move around. Whereas if you only had to have one person be able to build in this, one person be able to build in that, and they can build different components and put it together, or one team, I should say, an enterprise is going to find that very useful. Yeah. So I can definitely see the value there, especially if you're building on what is the de facto operation system, which is Kubernetes right now. So that makes perfect sense.
So we talked about a lot of the component stuff in terms of benefits it gives to developers. There are fun parts that you can do on the runtime side of things as well. And part of 3.0, we actually released a feature we call selected deployments. It means that you can define, so considering the scenarios, when you write a Spin application, you can expose individual components. It's typically HTTP endpoints, right? Because these are serverless function models. So you create an HTTP event, an HTTP handler. Within that handler, you can take dependencies and other components that you bring in, but you can also split up the applications in multiple handlers. With selected deployments, what you can do is now, if you go and deploy this into Kubernetes, for instance, you can actually define which components you want to deploy on various node types or node pools inside of your Kubernetes cluster, even if there's some of them you don't want to deploy. So there are lots of benefits you can get on the runtime side once you have things broken out into components. One of those being this breaking up the application. Another thing we've done as experiments in other runtimes is deduplicating components. If you know Windows and .NET, there's a global assembly cache concept in .NET. I think it's actually a .NET concept. It must be outside of Windows as well. Anyways, I used to know about it from Windows back in the days. But basically at runtime, what you can do is, let's go back to the example of the image transformation. Let's say 100 people deploys applications into your system that all makes use of that same image transformation component. We only need to host it one time, and we actually in the system. And all of these applications and other components that make use of it will just run that. So there are lots of great things you can do there, both in terms of less footprint at deployment time. But going back to your enterprise scenario, Laura, again, there's things like how can you actually patch things in the system? But you can just upgrade that one component if there's a security thing that needs to come in, and now all the applications are using the updated, right? Even if it's in a distributed system and not necessarily on a single machine.
That makes sense.
Yeah.
It's a good model.
Yeah.
Useful model. I'm just thinking in terms of massive enterprises with lots of things going on and just only having to fix it once and having to stay up once to do a deployment in the middle of the night is very nice.
Yes.
Instead of having to have 4 deployment windows that I have to go deal with over the course of a week to handle a security vulnerability.
Let's get away from the enterprise chat because we don't want to offend the cloud native folks. Okay. And no, what I'm thinking is,
Don't they work in enterprises?
yeah, small ones.
Okay.
Little ones. It's not that bad.
No, I don't know. Maybe it's just my clouded judgment. But enterprises, I hear Java, Tomcat, scary stuff, virtual machines.
Hey, suppose
data
like
centers.
that could work on here, right? Maybe?
What? Sorry?
Java. I'm just kidding. David, and just look
I
horrified.
think she's trying to
I'm
convince you
working
to
on it.
build the WebAssembly Tomcat. That's
No,
what it
thank
is.
you. I'm good. I'm more just trying to horrify you, David, so it's all good. Anyway, what was your question?
No, I was thinking, I think we've said lots of nice things about WebAssembly. We're seeing momentum, there's pace, there's velocity, all these wonderful things we want from a budding new ecosystem. The next wave of cloud computing, if you will, right? How are Fermyon approaching the idea of getting individual developers to say, okay, I want to write my next thing in WebAssembly? Because I imagine that is a challenge, right? People are so set in their ways with ready to go and shipping containers and sticking them onto Kubernetes. What does it look like? I'm assuming you go to conferences, you speak to people, they have that aha moment, but they're like, this is really cool. How do you deliver that to the individual developer? Then I'm sure they eventually go to an enterprise, but I don't care. But how do you put that smile on that developer's face?
We show them the thing, right? That is actually, it's hard to do in a podcast like this. I think one of our taglines is like 66 seconds from blinking cursor to deployed application. Like the lightweightness, I don't even know if that's a word, but of the whole thing, just to have I think it's enabled us to being able to create like one of the best developers experience I've been part of creating. To give you some of those examples, there's a simple CLI tool that you download. And by the way, we didn't talk about this yet, but both Spin and SpinCube, the project to get things into Kubernetes, are becoming CNCF sandbox project at the moment. They're
nice.
in the process of onboarding. So this is now a CNCF based project. There are other CNCF projects around WebAssembly as well that people should go and check out. So it's been open source all along, but it's not a Fermyon owned thing anymore. It's now in the CNCF, which is super nice. You download a CLI, and that's really all you have to do. You need your programming language tool chains, and there aren't like heavy dependencies. I know container runtimes are probably almost everywhere again, so whether that's a heavy dependency or not, but you still need it if you want to run containers, right? And even if you want to do Kubernetes stuff, you either run K3D or micro K8, whatever you do locally and all of these things. None of this is needed here. So being able to go through that experience of having just the CLI, writing a simple function handler, running it locally, where you get built-in key value stores and other things that we can do, again, because of this whole WASI model. Like we can plug in underlying data store implementation through those interfaces, and being able to deploy that either into Kubernetes cluster and SpinCube or into a managed service like Fermyon Cloud, which is run these serverless functions at scale. That is 66 seconds to have things in the cloud, which I find it super, super hard to get to anywhere elsewhere. I know when people talk a lot about, typically when people talk about PaaS, they always end up referring back to Heroku as being sort of the golden standard of how you want to build a good developer platform. And I think we've actually come super, super close to that without having to lock people into particular programming languages or frameworks or other things that they can do, because it's all based off WebAssembly and the standards that are behind that. I hope some of those things are the things that would put developers smile on, which I felt was part of your question as well, David. Definitely SpinCube is one of those, like making it super, super easy to have a place to run these things, right? Starting to see some enterprises experimenting with lighting up SpinCube as part of their Kubernetes-based platforms really just gives developers the deployment endpoint that they need to start running these things.
Yeah. I was really hoping that you went down the developer experience angle, and you totally did. So that's fantastic, because you mentioned Heroku there. And I'm old enough that I remember when Heroku deployed or launched, and I shipped my first thing. And I didn't write a single config. I just did a git push to a remote. It wasn't mine. It was the Heroku client. And all of a sudden, it knew what type of application I had. It put it into production, and it spat out a URL. And that was a moment, that's a eureka moment. That's wow, like deploying has never been as easy before. And I think for Spin, for me, and I can't remember when this was or whatever, but it was when the spin add command was added, and I was able to just add new multi-language, polyglot, whatever you want to say, components to a single application where all the routing was handled for me, and I could invoke each different thing easily. That was, oh wow, like this changes the game, because it just gets rid of so many different challenges with writing applications in this way. We look at Kubernetes, and can you be successful with Kubernetes on its own? But really, you need service meshes, and you need observability tools, and you need GitOps, and you need platform engineering and all this stuff. And then you get Spin coming along, and you just do Spin deploy and Spin build and Spin up. And it doesn't matter how many components are, it just handles that for you. And like, show me a better developer experience, anyone. Like, that's an open challenge. Like, I just don't think one exists. Okay, I feel like we're doing a nice journey here, and we're getting close to wrapping up. But we'll put smiles on developers' faces. They see the magic. And now we're talking about productionization. There was something that caught my eye with Spin v3, which was the open telemetry integration.
Yeah.
Maybe you can share a little bit of light on, as we move to pushing more WebAssembly into production, how important that is and what's coming next.
Yeah, the main thing we did in Spin 3.0 is actually to have the runtime being instrumenting the path to invoking your components. So think about it as a runtime. Your app is like the guest running on top of the runtime, which means that out of the box, and there's actually we have called them plugins to the Spin CLI, the developer experience. So you could run a command called spin plugin install OTel. And then when you do the local running of your Spin application, which obviously is the command spin up, you do spin OTel up. And if you do those commands, what you get is a local Jaeger instance that just immediately shows you the spans when you call into your WebAssembly components. And you can start imagining how you can see a span of a request came in, one component was loaded, that component called another component, may have called a third component. And when we get async, you can start seeing those things coming back, and you just get all these spans and things out of the box. That also is translated into SpinCube. So when you deploy things into SpinCube, you can either have a global or namespace scope or whatever your scope is, OTel configuration. So all the Spin applications just start pushing traces and spans into your OTel instances. So I think the main thing there is just going where the ecosystem already are, right? Or is where it's just, if you build a platform based on Kubernetes, there's a high likelihood that you have some OTel-based monitoring system, observability system already. So obviously these workloads just need to fit into that ecosystem as easy as possible. And again, taking it back to the developer experience, let's just take some of those concerns away, because if we have a good enough solution that solves for the 80, if not even more use cases, Why even make it your concern from the get-go, right? You get stuff out of the box, and obviously you could be able to start implementing your own spans and so on and so forth in the code that you write, but really out of the box, you get all these things where you can start just measuring the execution time of your component and so on and so forth, and have that as, a thing you don't have to think about, but it's just there.
Makes sense.
Awesome.
Yeah.
All right. Last question. What's next for Spin?
Main thing right now is actually the whole CNCF onboarding. It's quite a piece of work getting it in, and it will probably resolve in a 4.0. Main reason being we have to do breaking changes of a bunch of namespaces and things in there that were previously assigned with associated with Fermyon as a company, which will now be, I think I was Spin framework. I don't know. I think the GitHub is called Spin framework now, where both Spin and SpinCube will land. So there's a whole bunch of work that we actually have to do to wrap all of that up. But obviously WASI 030 is a little bit of a way out in terms of timeline for the specification. But our hope is that we'll be able to contribute a snapshot of WASI 03 in the next release of Spin. And other than that, I think we've spent a lot of time on really improving the JavaScript experience. It would actually been more interesting to talk about the JavaScript SDK version 3 and the upcoming version 4 of JavaScript SDK, but that could maybe be another episode. But a lot have happened on the JavaScript side to make that a much more pleasant experience around Spin. Other than that, given it's a CNCF project now, everyone is able to come and contribute to what the roadmap should look like and their ideas and what they would like to see from the framework. So I highly encourage everyone to seek that out and be part of it.
Good luck with that transition.
Thank you.
It's a good road to be on. It's
Yes.
a long road, but it's a good road.
It definitely is.
I mean, are we casting bets on when the Linux Foundation launches the WebAssembly Foundation? Because surely that's right around the corner. There's a DevRel Foundation now, so why not WebAssembly one? That makes more sense.
That's fair. That's fair.
Don't worry, I'll cut out. I'm not going to moan about the Linux Foundation on this. I could. All right, any last questions, Laura?
No, it's just always good to hear a little bit more about WebAssembly. And I know just itching David's oh shiny itch is always a good thing too.
All right, then we'll give Mikkel a chance to say goodbye. Do you have any parting words or anything you'd like to share with our audience?
Oh, thanks. Thanks for having me here. Thanks for inviting me to come talk about WebAssembly. It's always good to see you guys in person.
Thank you for coming on. It's been good.
Connor's right around the corner. Right?
Oh yeah, that's true. That's true. I will definitely be there. Also, there's WASM.io just the week before. So if you'd rather go to Barcelona Thursday, Friday, and maybe stay over the weekend, I'll definitely recommend coming to WASM.io.
There you go. There you go.
We'll include the links in the show notes. I see you in London. To everyone who listened, thank you for joining us.
Yeah.
Thanks.
Thanks, folks.
Thanks for joining us.
If you want to keep up with us, consider subscribing to the podcast on your favorite podcasting app, or even go to cloudnativecompass.fm.
And if you want us to talk with someone specific or cover a specific topic, reach out to us on any social media platform.
Until next time, when exploring the cloud native landscape, on 3.
On 3.
1, 2, 3. Don't forget your
Don't
compass.
forget your compass.